In this lesson, we are going to solve one-step inequalities. So sometimes inequalities come in the form of things where you have to actually do some manipulation to find out what x is less than or greater than. And so in this case, this is a lot like just solving an equation. So if I were to think of this as if it were just x over 3 is equal to 4, then I would solve it just like I would solve an equation. Since this is division, I would multiply both sides by 3. And so the 3's would cancel or divide out and make 1x, or x is equal to 12. Now that's if it was an equality, but that's not what the symbol was in the middle, so I need to replace what I did here with this symbol and simply rewrite it as x is less than or equal to 12. If I left it like this, it would not be true. So really I don't need to do what I did here, but for some people sometimes that symbol just kind of throws them off, and so if it bothers you to see this symbol, you can just think of it like this and then replace that symbol back at the end. So I'm going to leave it alone this time and not put the equal sign in there because you don't need to. This symbol is just fine. It's another representation. It's just saying x minus 1 is greater than 5. Since this is x minus 1, I'm going to add 1 to both sides, just like I did when I was solving equations, because I'm going to do the opposite. The opposite of subtraction is addition, and so then that becomes 0. So x is greater than 6, and that's my solution. X is greater than 6. So these are one step. It should just take me one thing to solve these. So if this is 6 times x is less than or equal to 10, so if I divide both sides by 6, then I will know that x is less than or equal to, now I actually have an improper fraction, so it would be 1 4/6, which I could reduce to x is less than or equal to 1 2/3. So, and still solve them even when they don't come out nice and even. So, and again, it's a one-step solution, so all I'm trying to do is solve the equations now. So here is addition. X plus 8 is less than 11, so I need to find out what x is less than. So we're going to get rid of the 8 by adding the opposite to both sides. So x is less than 3. 11 minus 8 is 3. So there's my solution. And it's an inequality, so that's the inequality symbol that needs to basically come through the equation. Now I have division. X divided by 2 is greater than 7, so I'm going to multiply both sides by 2. So the opposite of division is multiplication. So we're always doing the opposite operation when we have one-step problems. We're either opposite of multiplication, opposite of division, opposite of addition, opposite of subtraction. In this case, it's division. 2 divided by 2 is 1x, or x is greater than or equal to, so we don't lose the symbol. 7 times 2 is 14. So there's my solution. X is greater than or equal to 14. As long as I keep this symbol in between, I'm really not doing anything different than if I were just solving an equation with an equal sign in the middle. So again, let's continue. X minus 3 is greater than 12, so add 3 to both sides. And we'll get x, and bring the symbol down, greater than 12. And 3 is 15. So x is greater than 15. These are all one-step problems, so that we should have just one basic step, basically doing the opposite of whatever's there. So this is 14 times x is less than or equal to 2, so we're going to divide both sides by 14. Opposite of multiplication is division. And so we get a fraction for an answer. 14 divided by 14 is 1x. And 2 divided by 14 is 1/7. So we have a fractional answer, but that's just fine. Now this one might throw you off a bit because it's 9 plus x, but the x is just a positive x and we just leave it as it is, and we need to get rid of this 9. So to get rid of the 9, we subtract it from both sides. And so we end up with a positive x, or x, is less than 16 minus 9 is 7. So there we are. Not so hard. So just like solving equations, we're going to do the opposite of everything we see. Opposite of divided by 5 is multiply by 5. So x, 5 divided by 5 is 1x. And that's greater than 1 times 5, which is 5. So x is greater than or equal to 5. And you can kind of see that if you put the 5 in there, 5 divided by 5 is 1. So anything bigger than that is going to be bigger than 1. A 6 over 5 is more than 1. A 7 over 5 is 1. Everything bigger than 5 is going to give you greater than or equal to 1. So you can always go back in these, and if you're not sure, if I think about this last one here, 9 plus 7 is 16, but it has to be greater than 7, so anything, even the slightest 7.1, a 9 plus 7.1 is greater than 16, so it works. Okay, just a few more examples of this. So x minus 4 is greater than 6, so I'm going to add 4 to both sides, because I'm doing the opposite of what's there to make it go away. Negative 4 and a positive 4 make 0, which is why I did that, to make the 4 go away. And then greater than comes down. X is greater than 10. 6 plus 4 is 10. Divide by 18, because it's multiply. Divide by 18. 18 divided by 18 is 1x, is less than or equal to 3 divided by 18. Actually, it can be reduced to 1/6. Because 3 goes into itself once, and 3 goes into 18 6 times. So we're going to reduce the fraction as well if we can. So x is less than or equal to 1/6. And finally, we have x plus 7 is less than 15, so minus 7. X is less than, because the 7 goes away. 15 minus 7 is 8, so x is less than 8. And again, you can always check, because if I do 8 plus 7 would make 15, but that's not less than 15, so it has to be anything less than 8. 7.9, 7.99, however many 9s you want to put on there, will still make it less than 15. And so that's how you solve one-step inequalities.